not in a perfect square format, and it's difficult to identify. And they say, okay, identify the graph of each equation without completing the square. Fine. It's a parabola if only one variable of the two variables is squared. Here it is. Only one of them. So this is a parabola. Is there another that has only one variable squared? No. So this is the parabola. It's a circle if both variables are squared, positive, and have the same coefficient. Can anyone tell us from 14, 16, 18, and 20, which of these have both x and y squared, both positive in front, in other words, and they both have the same coefficient? Is anyone with me?
14 and 20?
14 is good, but it doesn't have the same coefficient. If they don't have the same number in front of x squared and in front of y squared, it cannot be considered a circle. So 14 is not. Which other one you mentioned?
20?
Yes, I agree. So we identified that 12 was a parabola. We identified that 20 is a circle, no doubt. Okay, it's an ellipse if both variables are squared and positive, but have different coefficients. So we are looking at 14, 16, 18. Both variables are squared, both terms with the squared variables have positive coefficients, and they are different. 14, 16, or 18?
Is this one 14?
Exactly. Finally, it's a hyperbola if both variables are squared, but one of them has a negative coefficient. Even if they are the same, it doesn't matter, because the circle cannot have a minus on either one of them. What do you think about 16 and 18? Are they both hyperbolas? The answer is yes. Either x squared or y squared has a negative coefficient. They are both squared. So both 16 and 18 are hyperbolas. Which one of these two has a vertical transverse axis? 16 or 18? Vertical. (16 or 18? It's okay if you're wrong. Which of the two, 16 or 18, has a vertical transverse axis?
Is it 18?
Yes, because x squared has a negative coefficient. Exactly, thank you. Correct. 16 has 4x squared. It's positive, so that's why the transverse axis is horizontal, like the example that we just looked at. Good. Okay, so let's continue with chapter 11. We have 3 sections to look at. This is just a very simple puzzle, which I consider a puzzle. I hope you're going to like it. But we have to go through these 2 first. Good. Okay, so first of all, let's define a sequence. a sequence of numbers. So chapter 11, 11.1 sequences. Here's an example. 5, 10, 15, 20, dot, 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 3 dots, comma, an, comma, dot, dot, dot. What does it mean? This is something called a sequence. It's basically a function that has for a1 is 5. a2, the second term of the sequence, is 10, and so on and so forth. This is the general term. We have different ways of presenting sequences. And here's one. B sub n with braces around it. So what does this mean? B sub n, and it shows 2n plus 1 over 2n. Again, I don't like the way this is presented. It should be explicitly identified that the beginning or the first non-zero number, that it doesn't have to start at 1. Maybe they consider that if it doesn't start at 1, they will specify. That's possible. But I think it should be mentioned. Sequences don't have to start from the first, from a equals 1. They can start at 10 or 15. So we're asked in this particular problem. That's the first question. Write down the first 5 terms of each sequence. So remember, when n is 1, we get this. The term is called a sub 1. When n is 2, we get this number. The term is called a sub 2. So here we will write bn equals, we plug in 1. 2 plus 1 is 3 divided by 2. So it's 3/2. When n is 2, 2 times 2 is 4, plus 1 is 5 over 4. When n is 3, 3 times 2 is 6, plus 1 is 7 over 6, and so on and so forth. They're asking us to write 5 terms. Okay, fine. So when n equals 4, 9 over 8, and 11 over 10, and dot, dot, dot. Yes, we can put the braces at the beginning. So this is the formula for the general term. We're asked to present, in other words, we are given this. And we're asked to present the first 5 terms of the sequence based on the general term. Of course, the general term is an expression that allows us to determine any natural or any positive integer. If you want 15, yes, I will plug in 15, 2 times 15 plus 1 divided by 30. In the next example, we're given something like this. This is an alternate sequence. Again, why? Because of this -1. And let's see what happens. And this is 20. So dn is -1 raised to n minus 1 times n over 2n minus 1. The same question again. They're asking us to present the first 5 terms. Fine, let's do so. Okay, so dn equals, when n is 1, 1 minus 1 is 0, -1 to 0 is 1. So 1 over 2 minus 1. I should write it as 1. I'll change it in a minute. When n is 2, 2 minus 1 is 1. -1 to the first power is negative. 2 at the top, 4 minus 1 is 3. When n is 3, -1 to 2 minus 1, it's 2. 3 minus 1, which is 2, so this is positive now. So 3 at the top, 6 minus 1 is 5. When n is 4, 4 minus 1 is 3. -1 stays as -1. 4 at the top, 8 minus 1, 7 in the denominator. One more. For n equals 5. 5 minus 1 is 4. -1 to the 4th is positive. So I have 5 divided by 9. And yes, ... Okay. Any questions, please? Now, write down the nth term, the general term, the nth term of a sequence suggested by the following pattern. Anyone would like to pick? Please do so. If not, I will.
Can you do 28?
28, perfect. In 28, we have 1 over 1 times 2, comma, 1 over 2 times 3, comma, 1 over 3 times 4, comma, 1 over 4 times 5, ... And now we want a sub n, the general or the nth term. Good. So let's see what we come up with. There is no change at the top. Nothing happens at the top. Perfect. Then what about the denominator? So I see that this is 1 unit larger than this. This is 1 unit larger than this. This is 1 unit larger than this. And they all go 1, 2, 3, 4. 1 more than this. 1 more than this, and so on and so forth. So obviously the first piece must be n. When n is 1, the first term is 1. When n is 2, I have 2. When n is 3, I have 3. When n is 4, I have 4. Can anyone tell us what to write in parentheses to signify this? Anyone would like to try?
N plus 1.
That's it. This is it. You can always take a moment and see if everything works fine. When n is 1, when n is 2, when n is 3, when n is 4, and so on and so forth. Well done. Thank you. Moving on. Do we want to choose any of this, or we move on to the factorial symbol? Are we choosing anything else?
We do 30.
Yep, perfect. Let's look at 30. 2/3, comma, 4/9, 8 over 27, 16 over 81, ... The question is the nth term or the general term. So we want an. Obviously, it's a fraction. Let's see the pattern here. 2, 4, which is 2 squared, 8, which is 2 to the 3rd, 16, which is 2 to the 4th. What do you think we should have at the top? When n is 1, I get this. When n is 2, I get this. When n is 3, I get this, and so on and so forth. Anyone?
2?
You mean 2 to the nth. When n is 1, I get 2. When n is 2, I get 4. When n is 3, I get 8. When n is 4, I get 16. Is this okay?
Yes.
What about the denominator? 3 to the first power, 3 to the second power, 3 to the third power, 3 to the fourth power. What will you say?
Three to the nth power.
Very good. In general, we prefer to write it like this, but it doesn't matter, both are acceptable. Perfect. Let's talk about the factorial. factorial symbol. It's this, the exclamation mark. What does it mean? Okay, 3 factorial means 3 times 2 times 1. 10 factorial means 10 times 9 times 8 dot 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 times 3 times 2 times 1. In general, n factorial is n times n minus 1 times n minus 2 dot 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 times 3 times 2 times 1. Now, you may or may not like this, but 1 factorial is 1, and 0 factorial is also 1. Okay? Now, they are asking us to evaluate some factorials here. Okay. Before we choose problems, I just want to mention one more thing. Let's say I have, or maybe we should work on an example. It's even easier. Like 12 over 10. So 12 factorial over 10 factorial. Which of these two is smaller? Of course, 10 is smaller. I can write 12 times 11 times 10 times 9, but I'd rather stop here. I have 12 times 11 times 10 factorial. Why did I stop at 10 factorial? Because I saw the denominator. I can simplify them. And then I have 12 and 12. So this is 132. I have 12 and 1. 12 times, yes. What did I do? Who knows? Yes, 12 and 12. That's correct. So I have 132. How do I do this with the calculator? The calculator is limited. So be very careful, because if you try to put something huge, the calculator will not give us anything. So in math, carefully get stuck on that. Okay, so go to math. And this time you have to go to probabilities. So scroll to the right, and then you choose 4. So if you want to choose, let's say 12 factorial, I didn't mean that. I meant 4. No, I don't want the answer. Okay, so let me put 12 and then factorial. That's what it was telling me. Okay, and 4. So 12 factorial may not be too big for the calculator, but if I change this to 120 factorial, the calculator probably won't be able to calculate it. So just 12 factorial is what? 479,001,600. If I repeat, so that's why we need to know how to simplify. I don't think that this will be able to calculate. I don't know. We'll see. Oh, yeah. So it exceeds the range of values the machine is able to display, right? So that's why we need to understand and be careful with these factorials and simplify them as much as possible before we put them in the calculator to see what we get. So 9 factorial, it will do it. That's not going to be a problem. No, I didn't mean that. I meant the previous entry. So this will do, because it did 12 factorial, but 120 factorial is not possible. So this is 362,880. What does it do? 9 times 8 times 7 times 6 times 5 times 1. What do we need this for? You'll see in a minute. So let's also simplify the 5 factorial. 5 factorial times 8 factorial over 3 factorial. We need the factorials. We need factorials for the binomial theorem. Okay, in a minute. Good. So again, you can put this in the calculator. Most probably it's going to do it. It's going to be able to. But here's what I prefer. 5 factorial I'm sorry, 5 times 4 times 3 factorial times 8 factorial divided by 3 factorial. So I only expanded this to 5, 4, and 3. I stopped at 3. Why? Because I wanted to simplify. So then I have 20 times 8 factorial. It should be able to do this with no difficulties. So I go back. No, I don't want to put it in yet. No, I didn't mean that. So I wanted to put 20 first, and then times the previous entry. I said times the previous entry. Why did it do that? Times the previous entry. Huh. Okay, fine. Fine. Good. And then 8. And then 4. And calculate. So the answer is 806,400. Any questions? Okay, the sequences can be given to us in several ways. This is one, when they list the terms. This is the other, when they give us the general term or the nth term. But some sequences are given recursively. What does this mean? They're giving us a relationship between terms. So let's take a look at 38. 38 says, write down the first 5 terms. 1 second, I need to start